Welcome back. Now, we know how to spawn actors dynamically from Blueprint, but now that we're not doing it in Blueprint, we want to do it in C++, so that's what we're going to cover in this video. Now, here's the documentation for the C++ function spawn actor, and it says it's a templated version of spawn actor that allows you to specify a location and rotation in addition to class type via the template type. So scrolling down, we see that this is a function on the world class, uWorld, and it's a template function. So we can specify the C++ class that we would like to spawn. Now, this particular version of spawn actor takes a location and rotation as well as a const reference to these fActor spawn parameters. fActor spawn parameters, if we click on that, we see that it's a struct of optional parameters passed into spawn actor function parentheses s, which implies that there are multiple spawn actor functions. There are multiple overloads of spawn actor. And spawn parameters contain a number of parameters we can set, and as mentioned, these are optional. So if there are multiple versions of spawn actor, why do we only see one here? Well, that's one of the shortcomings of the Unreal Engine documentation. I think it should show all the overloads here, but it doesn't. But that's okay. We can go back into Visual Studio. And in Breakable Actor, we know we'd like to spawn an actor here in GetHit implementation, the implementation on the C++ side for our Blueprint native event, GetHit, which belongs to our hit interface. Now, we know that this is a function on the world. So if we just quickly type getWorld, we'll have access to the world, and through the arrow operator, we can type spawn actor. And if we start the opening parentheses, we see that it says 7 of 7, which implies that there are 7 different overloads of spawn actor. And we can cycle through them by clicking the up and down arrows. Now, I'd like to cycle through and bring your attention to 2 of 7. At least on my version of Unreal Engine, it's the second overload. And we see that this is a function that returns an aActor pointer, and it takes in a uClass, as well as a location, a rotation, and optional spawn parameters. Now, actually, location, rotation, and spawn parameters all have default values, and if you omit them, then the actor will be spawned at this location and rotation with these spawn parameters, which is using the default constructor of the fActor spawn parameters struct. So we can really get away with not really passing in these parameters, but that means our actor will be spawned at location 000, as this is a C-style cast to an F vector with all zeros, but the point is that I'd like to bring your attention to uClass here. You see, the thing about spawn actor is it is a template function, meaning we have to pass in a type to the angle brackets. And we could pass in a type such as a treasure, for example, and we would spawn a treasure actor. But the problem with this is we're going to spawn a raw C++ class, not a blueprint. And remember, our treasure blueprint has additional information in it. If we go into our blueprints folder, not for Medieval Dungeon, but for our project, here's blueprints, we can go into items and pickups, and here's our BP treasure. And it has some things set in it. Specifically, we set the static mesh. Now, the raw C++ class does not have this mesh information. In fact, the item mesh is created in the constructor, but that component has a static mesh variable and it's not assigned. We assigned it in the blueprint. So simply calling spawn actor, specifying a C++ class, will spawn us a C++ class object based on a treasure, but it won't have its mesh set. Now, this presents a unique problem. We want to spawn an actor based on a blueprint, not the C++ class. So how do we go about doing that? Well, if I remove that angle bracket there so I can Control-Shift-A to get this pop-up back and go back to Overload 2, that's where this uClass comes in. So let's talk about uClass for a second. Now, we know that we can call spawn actor passing in a uClass. as well as a location, a rotation, and optional spawn parameters. So what is this uClass? Well, we know that spawnActor is a template function, and we specify a type in C++, and that determines what C++ class is spawned. But uClass is an additional class parameter. It's kind of like the type we pass into the angle brackets, only uClass allows us to specify more than just a C++ class. We can specify a blueprint class. Now, if we're passing in a uClass and we just want a regular C++ class, then we can always satisfy a uClass input parameter by taking any class that's derived from the uClass class and calling its inherited static class function. Static class will return a uClass pointer that represents the type of that class. So think of it as a type rather than a pointer to an object. Like I said, it's sort of like the type we pass into the angle brackets for a template function. It specifies what the function should do. In the case of spawnActor, it will opt to spawn that class that we specify, even if it's a blueprint. So static class gives us a raw C++ class in the form of a uClass pointer. But what if we want to specify a blueprint class? Well, we could use this uClass type. If we have a uClass pointer on one of our classes and we mark it with uProperty and give it a specifier that allows us to edit it in the details panel, such as edit anywhere, then we could choose the class for this, and it could be a C++ class, or we can choose a blueprint class. Then we'll have a variable in C++ that represents a blueprint that we've created in the editor. And that comes with any data on that blueprint, such as any static meshes that we may have set on it. So why don't we see how that works? So here in breakableActor.h, I'm going to add a new private variable, and it's going to be a uClass pointer. And I'm going to call this treasure class. And I'm going to make it a uProperty. And I'm going to give this uProperty edit anywhere. Now, I can go ahead and save and hot reload from within the editor. So let's do that. So with live coding completed, I'm going to go into my breakable actor. So in blueprints, I can go into breakables, open BP breakable, and here in the details panel, I can search for my treasure class. And here it is. It can be set here because it's edit anywhere. And this is a uClass variable. So if I click the dropdown, I see all the values I can assign to it. Everything here is based on uClass, somewhere up the inheritance hierarchy. And that includes blueprints. So I can search for BP treasure, and I can choose that. And now my treasure class here in the editor is set. That means I can pass that in as a uClass to spawn actor. And then I can spawn an actor, and the actor that we have spawned will be the blueprint rather than a raw C++ class. So why don't we go into breakableActor.cpp and simply spawn one of these. Now we know that spawnActor is a function on the world, so we can make a uWorld pointer called world and use getWorld to set it, and we can check if world is valid. If it is, we can get world and call spawnActor. Now, I'm going to use the angle brackets and specify a treasure. Now, that means I need to include the treasure header file. So at the top, I'm going to include treasure, which is in the folder. Let's take a look. It's going to be in items. So we can include items, treasure.h. Now we can use this class. So we're going to spawn an A treasure, and we're going to use the overload of spawnActor that takes a uClass. And we have a uClass, it's treasure class. Now, before we use that, let's make sure that it's not a null pointer. If we had forgotten to set it in the blueprint, it would still be null. So we're going to check if treasure class is valid here first, and then we'll pass in treasure class. Now it sees that we're using an overload that takes a uClass, and it's showing us 5 of 7. But if we go back up to 2 of 7, we want to use this one, which takes a location and rotation. Now, I'm going to use the location of the breakable actor raised up by 75. Now, for this location, I'm going to make an f vector called location and initialize it with getActorLocation. And then I'm going to take that location.z and add 75 to it with plus equals 75.f. So location is the location of the breakable actor raised up by 75 units, so I can pass location in. And for the rotation, I'm just going to call getActorRotation right in here. And it's as simple as that. And as long as treasure class is set from the blueprint, which we just set it, then we should see an actor get spawned. So I'm going to click Save All, hop back into the editor and start live coding. And with live coding complete, I can just double check to see that I do have treasure class set here. I'm going to compile and save that, press play, and break some pots. And there's our spawned actor. So that's excellent, but I'm going to point out one thing, and that is if we go and find that treasure, which is under breakable actor down here, kind of hard to find without a category, but if I open the dropdown, notice I can select any number of values to populate this with. And really, we only want to set this to a treasure or something based on the treasure class. So just making a uClass variable makes this way too wide open, and you can choose any number of things here, and you may not want to be able to choose any number of classes for this. So for that, we can enforce a restriction on this variable by specifying that it should only be based on treasure or anything derived from treasure. And to do that, we use something called tsubclassof. Tsubclassof is what we refer to as a wrapper. A wrapper is a struct, usually a template type, which is designed to wrap around a pointer. It stores that pointer for us. They're usually templates, so they usually start with T. Now, if we made a tsubclassof specifying the aTreasure class, we could call this, say, treasure class, and make it edit anywhere, then what we have is a uClass variable, but it's wrapped in a tsubclassof pointer, which enforces the restriction that it can only be derived from the aTreasure C++ class or below. Now, our blueprint treasure is derived from aTreasure, so that includes blueprints. So why don't we use the tsubclassof wrapper? So we'll go back to breakableActor.h, and instead of using a raw uClass pointer, we can use tsubclassof. And in the angle brackets, we can use aTreasure. The only thing is, we're not including treasure here in breakableActor.h, so we should forward declare it. Now, we could forward declare it up at the top, but here's a nice little tidbit. You can actually forward declare right where you're using that type. So we can even forward declare here in a tsubclassof. So now that we're using this wrapper, let's save all and go back and hot reload again. All right, so we've live coded. Let's go back to BP Breakable, and we'll select BP Breakable Self, and under Breakable Actor, here's our treasure class, which is now a tsubclassof. Now let's see what happens when we expand the dropdown. Notice that our selection is much more limited. Because we specified the aTreasure type, we can only choose types based on aTreasure. That includes the treasure C++ class, that's what treasure is, and the blueprint based on that C++ class, which is BP Treasure. So tsubclassof makes our intentions much more clear and makes it less likely that someone could choose the wrong class. So whenever we need a uClass variable in C++, using a tsubclassof wrapper is generally the way to go, as this allows us to enforce some restrictions. Excellent. So now we're spawning a treasure whenever we break a pot, which is great. Now, I mentioned that I'd like the collision for these pieces to be disabled once we break this pot. As it stands, they kind of block us and we can't run through them, and that's a little bit annoying. but it would also be nice if our IK still worked with it. So rather than having our IK stand up on these box collisions like this, which doesn't look accurate, I'd like them to stand on the actual collisions of the pot pieces. Now, at the time of recording, there doesn't seem to be a very easy way to disable collision for the pieces once you've broken them. But here's a way we can do this. We can take our BP breakable and take our geometry collection and go down here to our collision presets and set it to ignore the pawn. Now, we can make sure that this is the case in C++ as well by going to breakable actor, and we're already setting it to ignore the camera. We can set it to ignore the pawn as well by copying this line, pasting it in, and changing this from ECC camera to ECC pawn. So we've set it in C++ and in Blueprint. Now that's step one, and if we press play, now we get the desired effect once we break it, but before we break it, we can actually run through it. And that's not what we want, but as soon as we do break it, if I can hit it, then we can run through and everything looks fine. And we can see that the inverse kinematics will still hit those complex collisions on the meshes for IK for the foot, but we do actually pass through them. We have no problem running through them. So that's good for when we break the pot, but what about before we break the pot? Well, collision can easily be solved with a capsule. Capsules are generally a good idea to use when it comes to blocking things, such as blocking our character from walking through a particular mesh. So we can add a capsule component here. I'm going to go ahead and add one into the protected section, as I would like to access this from blueprints. As soon as the pot breaks, then we can disable collision for it. So I'm going to add a uCapsule component pointer, and I'm going to call this capsule, and I'll just forward declare it right here on the same line. And I'd like this to be visible anywhere, blueprint read write, just like our geometry collection. That's why I made it protected. Now we need to construct this in the constructor. We know how to do that. So go ahead and do a brief little mini challenge, pause the video, and construct the capsule. And bonus points if you can set the capsule's collision response to the pawn channel to block. And go ahead and set its response to all other channels to ignore. See if you can figure out how to do that. Pause the video real quick and do that. All right, so we first need to construct our capsule. So we're going to say capsule equals create default subobject specifying uCapsule component. Now that means we need the include. And if you forgot, you can always see what that include is because we used it in our pawn. If we go back to pawns in the private folder and open bird.cpp, there's the capsule component include. So I'm going to copy that, close bird.cpp, and include it here in breakable actor. Now for the native internal name, I'm just going to call it capsule, and I'm going to attach the capsule to our root component. So we're going to say capsule setup attachment get root component. Now for setting the collision for our capsule. And it looks like I'm missing a parentheses there. There we go. Now we can say capsule, and I'm going to set collision response to all channels to ignore. That way they'll all be set to ignore, and then we can set the collision response to the pawn specifically to block. So I'll call set collision response to all channels. And this takes a collision response. So E collision response, and we'll use ignore. And then we can set the response to the pawn. So we can say capsule, and we can call set collision response to channel. I have it right here. I'm going to go ahead and paste that. And for the channel, we're going to choose the pawn. Look at that. It's right here as well. So I'm going to copy and paste that. And the response is going to be block. So E collision response, and we'll choose block. So the capsule will block the pawn. Let's save all, hop back into the editor, and hot reload. I'm in the habit of saying hot reload. By the way, I always mean live coding when I say hot reload. It's just habit to say hot reload. Technically, we're not hot reloading. That's the old way of doing it in Unreal Engine 4. But the new way is live coding, which I have enabled. So if you hear me say hot reload here and there, I'm really talking about live coding. All right, so let's let this live code. All right, live coding is done. Let's go to BP Breakable. And here's our capsule. And we see that its collision response to all channels is ignore, except for the pawn, which is set to block. Now, it is visible anywhere, so we can see it, and here's its details panel. We can change the capsule half height. I'm going to go ahead and adjust that and the capsule radius as well until these get to be the appropriate size, and I'll bring them up and position this correctly. Now, this is only for blocking our character. It's not going to respond to overlap events. It's not going to respond to a box trace or anything like that. It's just simply a blocking volume. And if we press play, we can try to run through, and we can't. But if we grab a weapon and swing, we can still smash. Now, there's one side effect, and we can see that by running show collision, hitting the tilde key, and entering that console command. We can see those capsules. And if we grab a weapon and smash, the capsules are still there, and we can't run through them. So we do want to disable collision for the capsule upon breakage. So we can access it here, and we can take capsule, and we can call set collision response to channel. And we're going to choose the pawn, and we're going to choose the response to be ignore. And now when we break it, then we should be able to simply run straight through and get the treasure. Perfect. All right, this is starting to look really nice. We're now spawning an actor. We're doing it from C++ this time, and we're using a T subclass of wrapper, and we've set that to be based on a treasure. So here under breakable actor, down here, we have treasure class. And it's a little hard to find by scrolling. We can always search for it, but to make it easier to find, we can simply give it a category. That way we always know where to look for it. So treasure class down here can be placed in category, breakable properties. So now it's in its own property. We can save all, and we've made quite a few changes. So I'm going to go ahead and save my entire project from within the editor, close out of it, and do a hard compile from C++. Excellent job. I will see you in the next video.